Okay, so let's talk about dilations. Unit 13, Lesson 5. So a dilation is kind of like when your eyes dilate. So a dilation is an image that gets larger or smaller, okay? Like when you make a copy, you can shrink it, or your eyes dilate, you can blow it up, a worksheet or a poster or something. So two words that they use are reduction and enlargement. You can call them other things. So a reduction just usually means that we are getting larger or smaller by scale factor. So it usually means that our scale factor is less than 1. An enlargement means we're going to blow something up, so our scale factor is going to be more than 1. If it's equal to 1, then it's not really a dilation because it stayed the same. Okay? So a dilation changes size, so it does get bigger or smaller, but it also moves it on the X and Y axis. So it is very specific. You can't just make it anywhere, so make sure you're plotting your points, okay? So sometimes you'll see other notation like you did for translations. You might see it like 2x and 2y, okay? That's one way you can see the notation, or they might just tell you what the dilation is, okay? So in example 1, we want to dilate the shape by 1/4. So that means we want to make this triangle 1/4 as big, okay? So it's really hard to judge that, but mathematically we can always find it. So I'm going to make up some fake points, A, B, and C, and I'm going to write those ordered pairs. So 1, 2, 3, 4, 5, 1, 2, 3, 4. And if you have a different strategy, that's fine as well. I find that this is the easiest. 1, 2, 3, 4, 1, 2, 3, 4. And then our C. 1, 2, 3, down 1. Okay, so those are our original points. So now for my new dilation, it's going to be specifically 1/4 of the size, but it moves it. And it's really hard to predict where and how it moves. So mathematically, I'm going to take both of these numbers times 1/4 or divide them by 4. So our new A, and you can write decimals as well, is going to be 1.25 and 1. Our new B, we're going to do the same thing. So 4 times 1/4 is 1. -4 times 1/4 is -1. And C, -3, so it could be -3/4, but really if I want to plot that, it's -0.75. And -1 times 1/4 is -1/4, which is really, okay? So then I just plot those ordered pairs. So we're going to go over 1 1/4, and you're estimating up 1. And then 1, -1. And then C. So it is the same shape, and sometimes it'll be inside the shape, sometimes it's out, but notice it's not the same distance from all the sides. So that's what I mean. I cannot predict it. I just have to do the math. All right, so the last shape, because usually this is pretty easy to understand, same thing, we want to dilate that by 2. So some people just make it twice as big. It doesn't always work out that way. So I'm going to let this be A, B, and C again. So our A is at 1, 2, 1, 2. And we'll see. If it does, it's just a coincidence, but 2, -1. And C is at 1, 2, 3, 4, -1. So now we have a scale factor of 2. So that really does mean to multiply all those numbers by 2. So our new A is going to be at 4, 4. B is going to be at 4, -2. And C, remember, multiply those by 2, is going to be at 8, -2. So I'm going to go 1, 2, 3, 4, 1, 2. B is at 4. And then C, 5, 7, 8, and then -2. And like I said, look, it didn't even keep it in the same spot, and we moved it twice as big. Okay? There's math reasons for why, but that's not important. We just want you to be able to execute it. So really the only work that you can show is just like what your original ordered pairs are. Okay? Good luck.